So today we're going to talk about measurement and fairness, and we will talk about what that even means. But it's mostly about a bunch of questions that we could ask ourselves when we are working on an automated decision-making process. It's usually machine learning, but it doesn't have to be machine learning. A little bit about me. I got my PhD in interpretable methods for cancer diagnostics, and then I turned being a machine learning consultant, and then that was when I turned into doing open source. I got involved with scikit-learn, and then I got involved with Fairlearn, and then I worked in an algorithmic privacy fairness team, and now these days I work at Hugging Face as a machine learning engineer. Some ground rules. For such a talk to work well, and for you to get the most out of it, it has to be a safe space, no judgment. If you have questions, if you have doubts, it is okay to ask them. It's okay to share those experiences. If you are already here in this talk, it means that you are curious, you want to know more. It's okay if you ask the wrong questions. There's no such thing as a wrong question. And ideally, when we go out, we don't judge others for their questions. It would be nice if we could keep the session a little bit interactive. So now, before we start, what I want you to do is to think of a system that is relevant to your work maybe, or you're curious about, or you're studying, and try to be very specific. For example, it could be a recommendation system, or a text search, or image search, or voice recognition, anything. And as we go through the exercise, it would be nice for you to go through the exercises for your own use case. And also, if you have questions related to the exercises we go through, ask them as we go. So now, I'm going to give you a few seconds to think about what you want to think about during the session. Right. Hopefully you have something by now. Now we're going to talk about fairness. It's very important to realize that it's a socio-technical issue. It is not an issue that we can solve by just doing math. And in most cases, when you start thinking about these issues, the problems can be solved not necessarily by changing your model or algorithm. You might be able to solve it or improve things by doing something in your data collection stage, or what people do with the output of your system. And it's really important to think about who are the affected people. We go into more details shortly. First, we're going to talk about different types of harms and some of the relevant types of harms that when you work in machine learning or like automated decision-making processes, they're kind of relevant. We are going to talk about allocation, quality of service, stereotyping, denigration, and over or under representation. Allocation. It means that if your system is used to allocate certain resources to people, then you might be harming a certain group if you're systematically not allocating that resource to that group. An example is when Amazon was going to deploy an AI-based system to scrap through the applications and choose the ones that go forward, and then people realized that the system is being very sexist. So they dropped that and they never ended up using it. Or quality of service, if you are, like this example is you take the image and then you detect the gender. First of all, the first question is, why do you need to detect somebody's gender from their image? If you want to know somebody's gender, you probably should ask. And you probably should think twice if you really need to know somebody's gender. But if you are, like, for some reason in a system where you want to do that, then researchers compared a few existing systems a few years ago, and they could see that the system works a lot better for people with lighter skin colors than darker ones, and it works a lot better for men than it does for women. It means that if you are deploying this as a part of another system that uses this as a feature, then you are being very inaccurate for a certain group of people. Stereotyping. This example is Latanya Sweeney, who's a professor, searched her own name on Google, and the ads that she got were all related to checking whether this person has any criminal history or not, or has she been arrested or not. And that's basically because she has a black-sounding name. If you look for a white-sounding name, you wouldn't get the same ads. And you're this person obviously hasn't been arrested. So if somebody searches for their name instead of up there being all ads or things related to conferences and her research, they're gonna see such advertising. The next one is denigration. Another high-profile case was when this image tagging algorithm tagged a picture of black people as gorillas. You obviously don't want to do that, but these are the things that you need to think about and you need to test for. And the next one is representation. You would look for CEO on a search engine, and you wouldn't get any women up there, and the first one in this example would be a Barbie doll, who's a woman. The first woman that you get is not even a human. Obviously these are the cases that people have talked about and search engines have improved. So if you search now, you get much better results, but these are the things that people didn't really think about back then. And it's also important to know that different types of harms related to a system that you deploy is not a single one. You might have one single system that is inducing multiple types for different groups. So who are the affected people? How do we think about that? It's not just your end users. You also need to think about direct or indirect stakeholders that you have. For example, you might deploy a system that affects a certain group of people, but that group has a profession that because of your system might change their behavior, and that change in behavior is impacting their customers. For example, if they're doctors, they're impacting their patients. If they're teachers, you're impacting their students. Depending on where you are, you might think about who are your legally protected groups, and then you go a step further and you think about historically marginalized groups of people. Again, this is not a universal thing. Depending on where you are, the answer changes. And it's also not really easy always to identify most relevant groups. And an example is, think left-handed people. The first release of iPhone and YouTube. Does anybody know what happened then? No guesses? Back then, YouTube realized that about 10% of uploaded videos are upside down. That's because all the engineers who tested the algorithm, the platform were right-handed, and they just ignored the metadata in the video that which direction the video is. It does show how also diversity in your team really matters, and it's not just about gender or race diversity. Any kind of diversity, it really helps your product. And obviously, the most relevant groups can be very specific to your use case, not just your company, the use case. If you're a large company, you don't want to have one team doing your fairness-related concerns and then dictate that to the rest of the company. You really need to go and check for every single use case. So, to recap, we talked about groups of people that might be affected and types of harms. I want you to spend a few seconds and think about the use case that you had in mind and what kinds of harms it might impact and for whom. And if you have questions or feedback, just shout. Yes?
So for allocation bias, is that always a type of harm? For example, in local government, we might have a scheme that is towards people who are pensioners, for example, that will give them an extra amount of money, say for example. If that doesn't target anyone that aren't a pensioner, so they're under the age of 65, is that actually a harm?
If I understand the question correctly, you're asking if allocation is always a type of harm, or if sometimes there might be a disparity but doesn't harm people? And is that the question? So when you think about it, the cases that get to the news or the cases that end up in the court, it's usually because a certain group is being harmed or discriminated against in a systematic way. That's why we focus on the harm and not just blindly checking for disparities between different groups. It matters whether what we're doing harms somebody or not, or a group or not. If not, then you are probably okay. Yes?
Imagine a case where you're allocating discounts to try and as part of a customer loyalty program, and you've built your model so you can detect people who've just temporarily fallen on hard times, and you want to help them. If a small proportion of those people feel denigrated by being offered discounts on cheap stuff, would that be a harm that would prevent you from running the program?
So the question is, if you are having a system which offers discounts to customers, and some people might be offended if they get discounts on cheap stuff.
Who you think are, or maybe between jobs or temporarily run into a cash crunch.
So you mentioned that you are targeting them because you think they have some financial trouble. The question is that what they perceive? There is a big difference between your intents and the perception. And if they don't necessarily perceive that, if the kind of service that they get, so this is a great example because which means that you have a system which probably detects whether somebody or whether your customer has financial troubles or not, and then you have another system which is going to offer them discounts based on the output of that model. Just doing that is okay, but then the question is that same model going to be used in a different system in your platform, and maybe not offering those same people a loan maybe, because you know that based on this system they have financial trouble, but you're not going to give them a 0% loan on the product that they could buy. So just giving them discount is not hurting anybody. It might be a resource that you're not allocating to another group that so it doesn't hurt people who do get the discount, it hurts people who don't. But it might hurt because of the way you made that decision, it might hurt these people who do get the discount because you prevent them from getting other services on your platform. And then that would be problematic. So now we get to measurement modeling. It's a framework borrowed from social sciences, specifically quantitative social sciences, where we deal a lot with concepts, and in that context they're called constructs, which are not necessarily measurable in an easy way. Think intelligence or political ideology. But we want to study these concepts, therefore we want to measure something. We want to have proxy variables that kind of represent those concepts and do stuff with them. In that language, we would say a measurement model is a statistical model that links unobservable theoretical constructs operationalized as latent variables and observable properties. As in, for example, I want to know somebody's socioeconomic status, I take their income as a proxy variable. Or I want to know what kind of outfits they care about, then I probably take their gender into account. It's like it matters why you are using a variable in your decision-making processes. And it's a lot about the fact that we make assumptions in the process from the very beginning when we start collecting data to how we use the outputs of our systems. And we would like to make those assumptions very explicit and then test those assumptions. So we start with a very easy example, measuring height. What can go wrong when we measure height?
Someone's wearing shoes.
Someone's wearing shoes. Very good.
You often get 5'11" people lying and saying they're 6 foot because it's socially desirable.
People lying.
Social desirability bias.
Social desirability. 5'11", yes, and yes. So the shoe is like definitely one example. Do we count that in height or not? Hair is another one. Do we count that or not? And then it's not, the answer is not very clear. Are we talking in the context of like a medical setting where the actual body height matters, or is it a social setting where the perceived height is more important than the actual height? If I wear platform shoes with like 5 centimeters heels like all the time, then I'm a taller person, like in all the social settings that I go. Also, like, how do I collect this? Am I taking pictures and guessing the height, or am I using a ruler, or do I scrap the data from a dating platform where people do lie? And then there was a study that showed that the bias is also not uniform, as in men exaggerate more often, and when they exaggerate more than women. So you have biased data, but it's also biased not uniformly for everybody. Now we talk very shortly about a few use cases that we're going to refer to later in the talk. Socioeconomic status. People usually take income as a proxy, and it can be just the value of the income, or a nonlinear, or some stochastic relationship to the income. But then there are questions: how are we measuring income? Is it before tax, after tax? Do we take insurance deductions? Does it matter what kind of insurance they have that are deducted from the income? How does that affect this socioeconomic status? Another one is measuring teacher effectiveness, which is a system in the US, where you have a system supposed to tell you how good a teacher is. How much added value does this teacher bring to the students? And what they do is that they take students' scores across years, or only that year, depending on how standardized the tests are, and then they measure some score for the teacher. Compass, probably the most well-known in the fairness literature. It is a system that is supposed to tell you what are the chances of this person being rearrested for a misdemeanor or felony in the next 2 years. Another one is measuring patient benefit, as in, do I want to refer this patient to another program and enroll them early so that if they have a complex health issue, they get treated earlier, and it helps them and it helps the healthcare system with like lower costs. But some less serious stuff, imagine a wine recommendation system. I just want to recommend wine based on the food that people are eating. Could that have issues? And another one, content moderation system. Think about having maybe a platform, a retail, or some content platform where people leave comments or reviews, and you want to flag and exclude things that are quote-unquote inappropriate. So, how do we test these assumptions? And why is that important? Again, from that article, leaving these assumptions implicit or untested obscures any possible mismatches between the theoretical understanding of the construct, what you wanted to measure, purported to be measured, and its operationalization, the Latin variable, the proxy variable that you're actually measuring. In turn, obscuring any resulting fairness-related harms. The first one is construct reliability, which is test-retest reliability. It is very much related to the concept of statistical precision, the inverse of variance. Meaning that if I'm measuring something, if I go and remeasure that thing, do I get the same result? For example, in the teacher assessment tool, there was a case where a teacher in New York City with 26 years of experience, the first year, he got a score 6 out of 100, and the next year 96 out of 100. It's very improbable that this person changed their value added to the students in 1 year after so many years of experience. So the value that I'm measuring is the effectiveness of the teacher, but it has such a high variance and I can't really explain it. So maybe I need to go back and like double check my system. Another one, socioeconomic status. I measure, maybe I'm a bank and I have access to people's data. Do I have a high variance for some individuals across months? It's very improbable that they change their socioeconomic status from month to month. Maybe the reason that I see that high variance is that they get sometimes their income at the end of the month, sometimes at the beginning of the month. And I was just doing a group by in Python and like getting whatever it is in a month. and like these are the things that none of these questions are really like, wow, such a smart question. It's more like there are a set of questions that if you actually bother to go through the exercise, you detect a lot of issues that would go unseen. Another one, content moderation system. I'm flagging comments. Do I flag them always the same way? Like if I have two similar comments, do they get flagged the same way? Or even like if I give this to multiple people, do they like flag it the same way? And if not, then maybe I need to have better guidelines and train my annotators in a better way so that I get a more consistent result. And the next category are about construct validity. We deal with questions such as, do these measurements look plausible? Are we measuring everything related to this concept that we wanted to measure? Or are there any, what are the consequences of measuring these or deploying these measurements? And it's a feature, not a bug, that the answers to these questions are not yes, no. It's a very gray zone, it's a spectrum. And at the end of the day, you need to kind of measure how much risk you have, how much in the right area you are, or how much in the wrong area you are. The first one is face validity. You can think of it as kind of a sniff test. You just look at the data, does it look okay? For example, do you have anomalies? Should you ignore them? If it doesn't look okay, maybe you imputed the data in a weird way, or the imputation went wrong. Or maybe you have a very unexpectedly high variance that you cannot explain. So this one you can measure in a quantitative way. And when we think about, for example, height measurement, I could go and check if the values that I have in my data set kind of agree with the data that I have from the scientific reports for the demographics that I have here. Or if I'm dealing with socioeconomic status, if the values don't look realistic, maybe I had the issue that in some countries they separate the decimals with commas, in some countries they separate them with dot. Another one is content validity, and it's about whether we completely understand and measure the concept we want to measure or not, and whether we are only measuring the thing that we wanted to measure. It has three sub-aspects: contestedness, some substantive validity, and structural validity. The first one, contestedness, it means if I ask multiple people, what does this concept mean to you, do they more or less give me the same answer? And if they don't, it means that probably a single number cannot represent that concept. And whatever you're measuring probably only one perspective. And it's not necessarily an issue that you're measuring one perspective. You need to document it. This is an assumption that you're making. You're making the assumption that this is what I want to measure, and you document that, and everybody downstream who's going to use this data or the output of the model knows that this is what you're talking about. For example, think customer value. What can we think about in terms of customer value and contestedness?
Maybe one aspect is like how much they spend versus maybe how many times they are a repeat customer. Those are two different angles on customer value.
How much they spend or how often they come.
And how often they come, which are two separate.
They're two different aspects, yes. When it comes to customer value, do we care about short-term value? Do we care really about whether or not they are going to buy something right now? Or do we care about this customer staying there and like buying something in a few months? Do I care about what they spend on the platform, or do I care about their loyalty and how much they refer others to the platform and how good or bad they talk about my platform when they talk to their friends? And these are very different things, and they need to be used differently based on what you really want to do. If you have a system that one team measures customer value and all other teams are using that value, it needs to be very explicit that what kind of value that team was measuring and whether or not that applies to your use case downstream. Another one is like when we are dealing with inappropriate comments in the content moderation case. why are we flagging something? Is it because it was racist, sexist, homophobic, etc.? Or is it because it's adult content and I don't want maybe to have adult content on my platform? Or does it violate a certain law? Which law? Or maybe I just don't want to have these comments on my platform. And making, again, these explicit and have the annotators writing down which reason they chose to flag this would help your modeling to also have different classes why you're flagging them. You can also then give the feedback to the customer why their comments are being blocked or hidden. And then they can correct that. Another one is substantive validity, as in, do I encapsulate everything that is related to what I need to encapsulate? For example, again, socioeconomic status and income. Maybe income is not the only thing that I care about. Wealth is another one, education is another one. By looking at the income, I don't necessarily get their status, but which one is really the one that is relevant to me? Or in case of like wine recommendation, did I only take into account the food, or should I care about the user budget or user preferences? Maybe it's a person who really likes red wine with fish. Like, who am I to judge? Or the regional variations on food and wine. I can't recommend something, I don't know, like if you go from country to country, especially in Europe, the preferences change massively. If I have one universal system, it's not going to work for everybody. Another one is structural validity, and this is more like if I do have assumptions, mathematical assumptions, or relationship between my variables, do they make sense? For example, if I have a causal diagram, do I have all the edges that are relevant, or are the direction of the edges correct? Or if I have a mathematical model, for example, in the case of the teacher performance, there is like the paper documents how it's calculated. Does that make sense? Or if I use a linear or nonlinear relationship to income for socioeconomic status, is that a valid assumption? So in this part, we talked about construct reliability, test-retest reliability. Then construct validity, first one was the face validity, which was kind of a sniff test, and then content validity. Some of these we can assess in a qualitative way, some of them quantitative. And we need to think about them both in terms of our inputs and output of the model. The next one is conversion validity. I'm going a bit faster because I'm out of time, almost. This means that if I have multiple ways of measuring the same thing, do they agree or not? For example, in the case of teacher performance, would I get the same kind of score if I took into account the peers and principals reviews of the teachers? It also raises the question, if I do have multiple ways of measuring the same thing, do I need a new way of doing that same thing? It might be like saving costs, but is it worth it? And then, even if I do have two different ways of measuring something and they both agree, maybe both of them are wrong. For example, in case of predictive policing, I am sending cops to a certain area, and then they are arresting people. It looks like I'm predicting the right thing because they go there and they arrest people, ignoring the fact that, cops arrest people where they are. If they don't go to a neighborhood, they're not going to be arresting people. Another one is discriminant validity, as in things that should be correlated, are they correlated? And the other way around, or not. For example, if I look at my socioeconomic status, and if I have data on gender and race, I probably should see some correlations because of the social structures that we have. Do I see those correlations or not? And then, do I want to fix for that? Another one is, if I'm measuring the patient's future care costs, does that correlate with race or not? And then a study showed that it was the opposite, as in I was referring more white people than black communities, but my black community was more sick. I'm going to skip these two. And then we get to consequential validity. This is where most of the fairness-related issues are raised. As in, what are the consequences of deploying this, this model? And we deal with questions such as, how is the world shaped based on my measurement? And is that the kind of world that I want to live in? And then if there are conflicts, do I want to change that? You can go through these questions regularly in your system. Who are impacted by my system? How does the system change the world? What are the consequences desired by the system? What are the positive ones that I want to focus on, and what are the negative ones that I want to mitigate? And for example, in the content moderation system, I might, like if it's in English, and then people of color and black communities kind of speak in a different way and write in a different way, am I flagging their comments with the same rate, with the same accuracy that I'm flagging them with people who write the way that maybe white people in the US speak, kind of, more or less? Or if I'm dealing with a language that is across a bunch of countries, like I'm dealing with German, and then I have maybe most of my data comes from Germany, but then Switzerland speaks like in a different way a little bit, and then you have Austria that speaks in a different way. If I have one language model, does it work for those countries or not? So now, the best part is thinking about fairness as a construct. When I talk about fairness in the machine learning space, we probably are going to measure that as its single value or a few values, and I want to optimize for that. Somebody says, make that better, or I want to make that better. Does that even make sense if you think about fairness as a construct? Yes? So the comment is like, isn't fairness biased itself? Something that is fair for somebody, it's another thing for another person. Yes. So it is kind of contested. As in like, what even fair means different thing to different people, somewhat based on their ideology. And we can like fight all day long like which one is correct, but it's just a contested context. It's also retest reliability, like you ask different people what was fair, as you said, no. Like most people don't agree. What that means is that it makes sense now that we have very different definitions of fairness. There is like, you can think of them, one aspect, like way of thinking it is like you have group fairness and you have individual fairness. There's also counterfactual fairness that we don't talk about. Individual fairness focuses on similar people should be treated similarly, but then the question is, what does it mean that people are similar? What do I take into account? And even if I'm taking everything into account, do I take into account what they are now, or do I take into account their past? Or do I take into account this individual's past, or do I take into account this group, the group that this individual is belonging to, and their, like that whole historical context? And then group fairness, we have many different definitions, and a lot of them conflict with one another. If you optimize for one, you lose on the other one. And the example is Compass, that it got into news because it would incorrectly score black defendants as high risk more often than white defendants, which meant that it lacks error rate balance. But the company says that, well, the probability of recidivism was high for individuals who scored high, no matter their race. So it does have predictive parity. Which one do we care about? And then also, like in group fairness, we really talk a lot about race and gender. Like these are the groups that we have, and none of these concepts are like very binary or very clear-cut measures anyway. So if you have a system, you really need to think about what are the aspects of fairness that you care about, what does apply to you, what kind of parities do you want to check for, what are the groups and communities that are affected, what are your legal risks and exposure. You might audit a system and you might see some slight disparity, but then the question is, do you want to care about it or not? It's important to document that, and it's important to check that, but sometimes you might be like, no, I'm fine. But at least you make that very explicit. And then also, there's a difference between the world that we have and the data that we have and the world that we want to live in. For example, if I'm in the case of hiring, do I care about hiring with the same rate that people are graduating from computer science? And for example, if I'm looking at gender, or do I want to have a company that has a better gender balance than people who are graduating? And then how do I deal with that? Which one is fair? Which one do I care about? And obviously care about intended and unintended and direct and indirect consequences of productionizing your system. This talk is kind of from a few different talks and papers. I've left the resources there. And now I welcome your questions.
Thanks, Adrin. Now we have 4 minutes for questions. I come with the mic.
How do issues of fairness interact with issues of data protection? For example, we can only gather data from individuals with respect to a given business purpose. And often we are told to work with anonymized data sets where key variables such as gender and race might be missing while their strong correlates remain unaccounted for. So if I am, for example, doing a medical predictive system, which is one of the domains I work with, I may not have race as a variable, so I cannot even check if the system that we're building might discriminate needlessly against one race versus another. What is best practice here?
Yes, so that's a great question. It touches on a few things. First is that that's like a lot also relevant, like when we talk about GDPR in Europe. We cannot collect that data. There is the complementary regulation coming out of Europe for responsible AI and transparent AI, where it does tackle those issues. So if you want to check for fairness explicitly, then you would be allowed to have that data. That's one part. Another part is some companies do choose to collect that data or use that data regardless of the regulation and pay the fine. And I know some companies do that because they want to do the right thing. Another one is on the technical side, there are also models that you train on partially known data. So some people opt in to share with you some of their demographics, and you try to build a kind of a fair model based on whatever definition you choose. And then you can show that that model is kind of fair for others, even though I don't know their demographics. So it like touches on a few things.
Thank you for the presentation. It's quite interesting. My question is usually about when dealing with models, the discrepancy that we have about the data that we would like to have and the one that we have, and the fact that we still need a certain level of discriminative power to run a business. And that word in itself, I think, makes clear like what many models do, right? Sometimes it's a classification problem. We are trying to separate different groups. And where do I draw the line? Say I'm a bank and I have to, with a very amount of data, I have to decide whether that person should receive a product. And say one of the few information that we have might be age. And as a group, I can say that usually younger people tend to be riskier. Where do I draw the line of being unfairly assessing the risk of those customers and being able to run a business? And I can use age, and maybe some people would say that's okay. But then obviously if I use race, that would be a step too far. But I said it's a step too far, but is age okay to begin with? And then this sometimes is never an ending conversation, so there may be no specific standards when it comes to this.
So it's this one is also a great question. I always say it shouldn't be the job of the data scientist who's developing to make that decision. What's important is for me to be, like, if I'm the data scientist, for me to be able to draw a parallel line and be like, hey, like, based on this metric, I can have this performance for this much fairness. And then the business makes a decision. And they make a decision based on the risk and profit factors. I'm not the one who needs to make that decision. I give them the option. When it comes to like choosing or not choosing certain attributes, it's the same thing. It's a lot of this is about making all of these assumptions explicit. and being very clear that we are using this information for this reason. And then again, the business can decide whether they want to go public with this information or just be private. But at least they have it. They're not going to be surprised if an auditor comes and starts like auditing their systems.
So let's thank Adrin again
I'll
for
be
the great
outside.
talk.